here is the video going over your Chapter 7 test review. So the first question is graphing a system of inequalities. So I'm going to graph these three inequalities, and then I'm going to find the shaded region that works for those three inequalities. I'm going to color coordinate. This one I'm going to do in purple. So I have 3x plus 4y is less than or equal to 20. I'm going to isolate my y, so I'm going to subtract 3x from both sides. So I have 4y is less than or equal to negative 3x plus 20. Divide by 4. I have y is less than or equal to negative 3/4 x plus 5. So since it's less than or equal to, that is going to be solid points with a solid line. So I'm going to go ahead and start by plotting 5. 1, 2, 3, 4, 5. And my slope is negative 3/4. So from this point I'm going to go down 3 over 4. Down 3 over 4. Opposite direction as well. And then I'm going to connect the dots and draw my line. Should probably use a ruler. That's okay. So my inequality says less than, which means I would shade below this line. So I'm going to make a note shading underneath that line. For my other one, I have x is greater than negative 3. So I'm going to go to negative 3 on my x-axis, open circle. And then I'm going to do a vertical dashed line through that point. And x is greater than negative 3 is everything to the right of that pink line. And then now y is greater than negative 2. I'm going to go to negative 2 on my y-axis, open circle, dashed line. And y is greater than negative 2 is going to be everything above that blue line. So I need to be underneath the purple, to the right of the pink, and above the blue. That puts you with this triangle right here. So you're going to shade it. And the shaded region is your solution. For number 2, solve each system by hand. You cannot use RREF for these, and the reason why you can't use RREF is because you have the x squared, so it's not a linear system, it's nonlinear. So what I need to do is I need to solve by substitution. You can do that a couple different ways. You can solve either the first equation for y or the second equation for y. I'm actually going to solve the first equation for y. So I have y equals x squared plus 4. And since y equals x squared plus 4, I can substitute my y in my other equation for x squared plus 4. So that leaves me with 2x plus x squared plus 4 equals negative 1. And then from there I can get it equal to 0. Since it's a quadratic, I'm going to add 1 to both sides. So I have x squared plus 2x plus 5 equals 0. I think I made a mistake somewhere, because that's not factorable. Oh, it should be y equals x squared minus 4. Let's change that. Sorry about that. Let's fix. Alright, so x squared minus 4. So let's fix this to a minus 4. So then when I add 1 to both sides, that gives me negative 3. Alright, let's keep going. Where did this line come from? Oh, geez. Technical issues over here. Negative 3. Okay, so let's factor it. So two numbers then multiply to negative 3 and add to 2 are x plus 3, x minus 1 equals 0. So my first possibility for x is negative 3. And my second possibility for x is positive 1. We still need to solve for y, so I'm going to take negative 3 and plug it in. So I have negative 3 squared minus 4. So that gives me 9 minus 4, which is 5. So my first ordered pair is negative 3, 5. And for my next one, I'm going to plug in 1 for x. So I have y equals 1 squared minus 4, which is negative 3. So 1, negative 3. So both of these ordered pairs is your solution for this problem. Number 3, you're going to do the same thing. The first equation has x squared and y squared and 25. What you cannot do is this, because it doesn't make mathematical sense, so don't do that. Instead, take the second equation and solve for x or for y. I'm going to solve for x, so I'm going to add y to both sides, so I have x equals y plus 7. From there, I'm going to do a substitution. So since x equals y plus 7, I can substitute into the first equation for y plus 7. So I have y plus 7 squared plus y squared equals 25. Y plus 7 squared, you need to multiply it out. It's y squared plus 14y plus 49 plus my y squared equals 25. Get it equal to 0, so y squared plus y squared is 2y squared plus 14y. I'm going to subtract 25 from both sides, so that gives me plus 24 equals 0. I'm going to go ahead and factor out the 2 since all of those have a 2 in common, so y squared plus 7y plus 12 equals 0. Factor further, so I have y plus 3 and y plus 4 equals 0. From here, solve for y, you get y equals negative 3 and y equals negative 4. With the 2, you don't have to solve for anything with that because it doesn't have a variable. So now that I know that y is negative 3 and negative 4, I can plug it in and solve for x. So I have x equals negative 3 plus 7. So I have x equals 4. So my first ordered pair is 4, negative 3. And for my second one, I have x equals negative 4 plus 7. So x equals 3. So my other ordered pair is 3, negative 4. And those two are your solution. Be careful when you're solving this, because if you'll notice, you're originally solving for y, and sometimes people have a tendency to change these to x's, which is going to get your ordered pairs incorrect. So just be careful, pay attention to your variables. Alright, what's next? This one you're solving using reduced row echelon form, so augmented matrix, RREF matrix, and the solution. So your augmented matrix is going to be all of the coefficients, no variables. So 1, 3, 4, 2, negative 2, negative 3. The RREF matrix is the one that you get from the calculator. So I'm going to plug it in. Let's see, this is a 2 by 3. So I have 1, 3, 4, 2, negative 2, negative 3. And that gives me a decimal, which I want fractions, so I'm going to hit math frac, and I get 1, 0, negative 1/8, 0, 1, 11/8. So my solution is going to be the ordered pair, negative 1/8 and 11/8. For my next one, doing the same thing. So I have 1, negative 3, 4, negative 2, 6, and 2. I'm going to put that into my calculator. 1, negative 3, 4, 2, negative 2, 6, and 2. And that gives me 1, negative 3, 0, 0, 0, 1. So if I look at my last row, that is telling me that 0 equals 1, which is never true, so this one has no solution. If you ended up with 0 equals 0, that would be infinitely many solutions, which would have to write a different way for your answer. Alright, 3 variables the same way. There is a small typo in number 6 that should be a z instead of an x for that last equation. But I have 2, negative 1 is 0 because I don't have a z, negative 5, 1, 4, 2, 15, 3, negative 2, 1, and negative 7. Let's put that into the calculator. This one is a 3 by 4. So 2, negative 1, 0, negative 5, 1, 4, 2, 15, 3, negative 2, 1, and negative 7. And that gives me the matrix 1, 0, darn it, 1, 0, 0, negative 1, 0, 1, 0, 3, 0, 0, 1, 2. So my ordered triple for this is negative 1, 3, and 2. And number 7, I'm going to assume this one has infinite solutions since we haven't seen that yet, but let's find out. So 4, negative 3, negative 1, 0, 1, negative 1, negative 1, 0, 3, negative 1, 3, 0. So let me put that into the calculator. 4, negative 3, negative 1, 0, 1, negative 1, negative 1, 0, 3, negative 1, 3, 0. Yep, infinite solution. So here's what the calculator gives you. 1, 0, 2, 0, 0, 1, 3, 0, and zeros all the way across the bottom. So if I look at the bottom, it's telling me 0 equals 0, which is a true statement, so that's infinite solutions. So what you're going to do from this is you're going to take your matrix and get it back into a system. So that 1 and 2 in the first row tells me that I have x plus 2z equals 0. And my second row is saying y plus 3z equals 0. So I can take both of these equations and solve for x and y. So this one I can subtract 2z from both sides, so I have x equals 2z. For this one I can subtract 3z from both sides, so I have y equals negative 3z. So now I can write your ordered triple. So my x is 2z, y is negative 3z, and of course z is just z. And you only have to do that when you have infinite solutions. Alright, word problems, everybody's favorite. So number 8, a grocer is mixing peanuts and chocolate to make a delicious chocolate peanut mixture. The peanuts she is using sells for $1.80 per pound, and the chocolate sells for $3.20 per pound. How many pounds of each should she use if she wants a 50-pound that will sell for $2.92 per pound? So I'm going to let P represent peanuts and C represent chocolate. And I want a 50-pound mixture, so if I take my pound of peanuts plus my pound of chocolates, that should equal 50 pounds. And then the peanuts are $1.80 per pound, and the chocolates are $3.20 per pound. And I want a mixture that is $2.92 per pound, and I am doing that for 50 pounds. So let's go ahead and rewrite my system. So P plus C equals 50. 180P plus 320C equals 2.92 times 50, which is 146. Now at this point you can solve the system however way you want. You can solve by substitution, you can solve by elimination. I would actually recommend just using the RREF in the calculator to make it go by a little faster. So here's what I'm putting in the calculator: 150, 1.8, 3.2, and 146. So I'm going to do RREF again. Oh shoot. Calculator troubles. Alright, so 150, 1.8, 3.2, 146. And that gives me 10 and 40. So I have 10 pounds of peanuts pounds of chocolate. So in terms of work, if you use the calculator, I would want to see the system and what you're putting into the calculator. And you can do this on the test too. You can just use the calculator for the word problems instead of solving the system by hand. Number 9, a total of $8,000 is deposited into 2 simple interest accounts. One account has an annual simple interest rate of 5%. The other account has an annual simple interest rate of 6%. How much should be invested in each account so that the annual interest is $450? So I'm going to let X represent the amount in the 5%. And Y is the amount in the 6%. And how much do I have to invest? $8,000. So X plus Y equals 8,000. And then for my interest, I have 0.05X plus 0.06Y equals, my total amount of interest earned is $450. So again, you can put this into the calculator. So 8,000, 0.05, 0.06, 450, because it's the fastest way to do it. And we're all about being efficient. Let's see, 8,000. Just make sure you type it in the calculator correctly. And that gives me 3,000 and 5,000. So I have $3,000 in the 5% account and $5,000 in the 6% account. All right, I think that's it for the word problems. All right, partial fraction decomposition. So the first thing I want to do is factor my denominator. So two numbers that multiply to 15 and add to -8 are -5 and -3. So x minus 5, x minus 3. And I'm going to set up two fractions. I'm going to have a over x minus 5 plus b over x minus 3. And what I'm trying to do is I'm trying to get a common denominator because I want to add these two fractions together. So what I would do is I would take a and multiply it by x minus 3, and b I would multiply by x minus 5. And when I multiply those two things, that should equal my numerator, which is -5x plus 29. So I'm going to distribute the b and distribute the a. So I have ax minus 3a plus bx minus 5b, and that should equal -5x plus 29. So if I look at my x terms, I have a plus b, and that should equal -5. And then for my constant, I have -3a, -5b, and that should equal 29. So -3a minus 5b equals 29. And again, you can use the RREF and the calculator to solve this system. So I'm plugging it in right now. -5b and 29. So from my calculator, I get a equals 2 and b equals -7. So to write my final answer, I would write 2 over x minus 5 plus -7 over x minus 3. So don't forget to put your a and b back in. For the next one, start by factoring the denominator again. So I can take out an x. So I have x times x squared plus 3. Now this x squared plus 3 is a quadratic factor that cannot be factored further. So what's going to happen is you're going to have to adjust your numerator a little bit when you set up your fractions. So I'm going to write this as a over x plus, and since this denominator is a quadratic, x squared plus 3, my numerator has to be something linear. So that's going to be bx plus c. And you only have to do that for a quadratic denominator that can't be factored further. But from there, I'm going to do the same thing. So a times x squared plus 3 plus bx plus c times x. And and that, of course, is supposed to equal my original numerator, which is 13x squared plus x plus 30. All right, let's distribute. So ax squared plus 3a plus bx squared plus cx, and that's supposed to equal 13x squared plus x plus 30. Let's look at our like terms. So I have ax squared plus bx squared should equal 13. And then I have cx should equal 1x, so c is 1. And then 3a should equal 30. This one you don't even need to plug in the calculator, you can just solve the variables as they are. So c is 1, we know that. For a, I have 3a equals 30, so that means a equals 10. And I can take that and plug it in right here, so that means b equals 3. So now I can write my solution. I have a, so 10 over x, plus bx plus c over x squared plus 3. All right. Number 12, how do you know when you have to do long division first with partial fraction decomposition? So the other two problems that we just did, we did not have to do long division. The only time you have to do long division is when your numerator, or the degree of the numerator, is greater than or equal to the degree of the denominator. So here's a few examples. So let's say I had 2x squared plus 3x plus 7 over x times x plus 3. Now my denominator is already factored, but if I were to distribute that x into here, that would give me x squared plus 3x, and my degrees are equal because they both have a degree of 2. Or here's another example. If I had 2x cubed plus 3x plus 7 over x squared plus 3. My degree in my numerator is a 3, degree in the denominator is a 2, so I would have to do long division first. All right, 13. So this starts the partial fraction, no, we just did partial fraction decomposition, sorry. This starts the linear programming. So this one already has the objective and it graphed the constraints. So you just look at your vertices. So I'm going to go ahead and create my table. So my first column of the table are the vertices. Second column represents the objective function, which is 4x plus 5y. And my third column is the value I get. So my first vertex is at 0, 2, and then I have 0, 4, 4, 3, and 3, 0. And I'm going to take each one of those vertices and plug them into my objective function. So I have 4 times 0 plus 5 times 2. That gives me 10. 4 times 0 plus 5 times 4 gives me 20. 4 times 4 plus 5 times 3 is 16 plus 15, which is 31. And 4 times 3 plus 5 times 0, which is 12. And I'm looking for the max and the minimum value. So my max is 31, and that occurs at 4, 3. And my min is 10, and that occurs at 0, 2. So the next one, I actually have to create the graph first before I find the max and the minimum value. Actually, this one just wants the maximum value. So let's go ahead and graph it. I want x is greater than or equal to 1, so I'm going to go to 1 on my x-axis. And that is going to be a solid line. Greater than or equal to 1 would be everything to the right. And then I also need x to be less than or equal to 4, so I'm going to go to 4 on my x-axis. 1, 2, 3, 4. Another solid line. Sorry, my lines are really crooked. Let me try that again. Oh, Lord. Alright. Third time's a charm. I really should be using a ruler. Alright, so that would be x is less than or equal to 4, so that's everything to the left. So right now we're in between these two lines. Y is less than or equal to 8. So I'm going to go to 8 on my y-axis. 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be a horizontal line. I'm much better at doing horizontal lines than I am at vertical lines, apparently. Less than or equal to 8 is everything below that. And y is greater than or equal to x. So that is in slope-intercept form. It's the same thing as x plus 0. So I'm going to start at 0. My slope is 1, because that's the number in front of x. So I'm going to go up 1 over 1, up 1 over 1. I don't like to plot every single point, so I'm doing up 2 over 2, which still gives you the same slope. But here is your line. And it needs to be greater than or equal to that line, so I'm shading above. So here is your feasible region. So now I need to find my vertices. So I have 4 vertices, and then I'm going to use that to make my table. What was my objective function? 2x plus 3y. And I am trying to find the max. So let's see. My first vertex is at 1, 1. I have another vertex at 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 8. I have another one at 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. And my last one is at 4, 1, 2, 3, 4, 5, 6, 7, 8, 4, 8. And I'm going to plug that into my objective function. So I have 2 times 1 plus 3 times 1, which is 5. 2 times 1 plus 3 times 8, which is 26. 2 times 4 plus 3 times 4 is 8 plus 12. I should not have to put that in the calculator. That's 20. And then 2 times 4 plus 3 times 8 is 8 plus 32. I shouldn't have to put that in the calculator either. Wait a second. I think I just put it in the calculator wrong. Oh, it's 32. Oh, 3 times 8 is 24. Duh. Alright, so we want the maximum value. So the max is 32, and that occurred at 4, 8. Alright, last problem. So for this one, this is the linear programming word problems, and for the word problems, I'm just going to have you write out the objective function and the constraints. So the B&W Leather Company wants to add handmade belts and wallets to its product line. Each belt nets the company $18 in profit, and each wallet nets $12. Both belts and wallets require cutting and sewing. Belts require 2 hours of cutting time, 6 hours of sewing time. The wallets requires 3 hours of cutting time and 3 hours of sewing time. The cutting machine is available for at most 12 hours a week, and the sewing machine is available at most 18 hours per week. So you want to maximize profit. So I'm going to let my objective function be P equals, and it says X is the number of belts, Y is the number of wallets. So the belts bring in a profit of $18, so 18x, and the wallets bring in $12, so 12y. And then for your constraints, you should automatically be writing x is greater than or equal to 0, y is greater than or equal to 0, because you can't have negative belts or wallets. And then from there, this problem is talking about 2 other things. We're talking about cutting time and sewing time. So those are going to be your 2 other constraints. So I'm going to look for the hours that it takes to cut the belts and wallets. So belts require 2 hours of cutting time, so that's 2x, plus wallets require, let's see, 3 hours of cutting time, so 3y, and I need to figure out how much time I have for the cutting machine. Let's see, the cutting machine is available for at most 12 hours, so that needs to be less than or equal to 12. So this right here is talking about the cutting machine. And then for the sewing machine, I have 6 hours of sewing time for the belts, so that's 6x, plus 3 hours of sewing time for the wallets, so 3y, and that has to be less than or equal to 18 hours. So this is talking about the sewing machine. So those are your 4 constraints. Yeah. So if you struggle with these, read through the problem, and one thing that I think about when I'm doing the constraints is I need to somehow have every single number in a constraint. So we did the profit, that gave us our objective function. We talked about sewing and cutting, so the sewing time was 6 and 3, and the sewing machine was for 18 hours, and then the cutting time was 2 and 3, and that was for at most 12 hours. So then that's how I know that I'm done with the problem. Alright, I hope this video helps you prepare for your test. Good luck studying!